All right, returning back to mock examinations, let's look at these radioactivity question, nuclear physics. It's very limited scope. It's a very easy question in this case, very basic information. What is meant by background radiation? Let's look at this. Background radiation is which does not require a radioactive source. I understand that the student's concept over here is right. What he's trying to say is right, but the words, they fail him. Because it's like trying to give you an example, like think about oxygen is always present in the air, right? There's always, but then in the hospital when somebody, God forbid, somebody is in need of oxygen, you get through an oxygen cylinder if oxygen was present in the air, because he needs more concentrated supply. Now in the laboratory, when we're using those sources that come from natural sources. Like uranium occurs in nature. It's not artificially made or anything. Yeah, some of these sources are artificially made, but most of them, they occur naturally. And but it's like, so we have to be a little more specific. So for background radiation, I would appreciate if you would always use the word, let me write it down over here. Background radiation that is always present, okay? Background radiation is always present in the environment or the surrounding environment due to natural sources. Now this would be a proper definition. Since not require a radioactive source is not it. It's something that is always present. Now these sources over a period of time, like 20 years ago, you wouldn't say food and drinks have it, but now because of the nuclear explosions that have happened, the Chernobyl reaction, the Chernobyl disaster in Russia, some of these radioactive spillovers have caused certain food to get contaminated that now contributes to background radiation. So radon gas has been natural, that is right. Okay, radioactive isotopes are used in some medical treatments. Okay, that's true. Is an isotope of radium. Radium-223 decays by the emission of alpha particles. So he's telling you that. What does it decay with? Alpha particle. To an isotope of radon. Okay. Now radium decays by the emission of radon and an alpha particle. So alpha 4-2, very good. And there are 2 marks for this. Complete the nuclide equation. So when you do that, 4-2 is 1 mark for that. And 223 minus 4 is 219. That's right. And 88 minus 2 would be 86. So this is where you made a mistake. All right, so this is wrong. Because 86 plus 2 should be 88, and 219 plus 4 should be 223. Okay. Now, radium-223 is injected into the body to treat a specific organ. Explain why the source must be inside the body. Now, in order to, let's say we wanted to treat something due to alpha radiation. Now, there could be multiple reasons. So the radiation does not spread. No, that is certainly not the answer. But what he's saying is it's injected into the body because we don't usually use alpha because it's highly ionizing. But let's say if for a specific organ it was required, it's because alpha radiation cannot penetrate the skin. All right, it won't be able to get in. So it has to be put in there. It has to be injected into the body. So it has to be injected into the body because the penetration is very, very low and wouldn't get into the body otherwise. All right, so because the penetration is low, it won't get into the body. It cannot penetrate through the skin. Now, an isotope of technetium is injected into the body to detect cancer in one of the organs. Now, to detect cancer. So let's say cancer cells absorb this technetium, and the half-life of this isotope is 6 hours. It's a very small half-life, and it decays by emitting gamma radiation. Oops, the radiation is detected outside the body. Explain why a source of gamma radiation is used. Now, we would use gamma radiation. There could be lots of reasons. I mean, you could think about gamma radiation being used for so many other reasons, but like, it's not ionizing and all that. But if you were focused onto what the question wants to know, is because why are they using gamma radiation now injected into the skin, into the body? Why would you inject? I mean, it could get into the body, right? But why you injected it into the body? So that cancers can be detected, so that when the cancer cells absorbs technetium and it's giving out, where the source is. So and the reason is because we want the gamma radiation to be able to come out of the body. So because gamma radiation has very high penetration, it'll be able to come out of the body, and then you will be able to detect it. So it can detect cancer and has high penetrating powers. That was good. That's right. So it decays. Now, short half-life, so we don't want it to stay for a very long time in the body, and we want it to go away. So decays quickly and does not stay in the body for long. Very good. That's right. Okay, so that's good. So this gives us 1, 2, 3, 4 out of 7. All right, let's just have a look at one more. Radiation, which is WHICH. We're exposed to naturally without any source. Without any source. You cannot say without any source. There is a source. This does not. Rocks, yes. 2198642, that's right. Alpha particles have very less penetrating power. That's right. Okay, it's stopped by the skin. Stopped by the skin. And won't be able to come out. So this is kind of like BOD. They are most energetic and penetrating, are used to detect cancers. This is where you get it. It's barely making it. Yeah. The phrasing, you know the answer, but the phrasing isn't cutting it. I mean, you need to say, because gamma radiation has high penetration, so we will be able to detect it outside. So he's not saying detect it. That's not the reason. He says detect cancer. The cancers. So there is a benefit of the doubt here. Gamma radiation can harm cells if exposed so that half-life is used, so the only stay for the purpose. That means, again, 1, 2, 3, 4, 5, 6. A good score, but it's because the answers are there, but not more like ambiguously. The radiation that is always present due to cosmic rays, always present. That's right. Cosmic rays. That's right. That's right. That's right. Penetrate through the skin. Very good. Very good. It can penetrate and travel through the body. Again, very good. To prevent too much radiation exposure, as longer half-life will cause radiation and source will be present inside for longer. Very good. 7 out of 7. And not just that, it's excellent as well. Very well explained. All right, thank you.